Hi, I'm GUO CHENG GUANG, Primary 6 from YUMIN Primary School. For this time, we are still at ordinary differential equations. In ordinary differential equations, there are many different types of methods out there. And why are there all these types of different methods? Well, it will help us solve these ordinary differential equations. But in the first place, where do we get all these ordinary differential equations? Well, those come from like physics, in astronomy, chemistry, all those different types of sciences that we will learn. So we're using different types of methods to show us how we can solve these different types of ordinary differential equations. At the same time, we'll also show some types of ordinary differential equations and like what kind of methods we need to use for these. And are there different types of ways we can use methods or a different type of combination of methods? Okay, so we'll achieve all these by exemplification. So for exemplification, that means we're just giving lots of examples. Now for this example here, over here, it is y prime. Prime means first derivative minus 1 over 1 minus x, then times y. And this is equal to 1 minus x bracket together times y to the power of 3 over 5. First things first, let's analyze this type of question or this question. Then we get a general form. Okay, firstly, this type here is first order. Okay, this is first order. Then over here, this is non-linear. This is not equal to 0. So that means it is non-homogeneous. So these 3 points. So we will be able to get a special type of pattern for this type of ordinary differential equations. And for this type of ordinary differential equations is what we call the Bernoulli Equations. Okay, this type of equations is general form. Y prime, which is first derivative, then you plus. Now this is a plus, but this is a minus. How is that possible? But let me just tell you, it's because of this px. Because px contains all these cases, whether positive or negative or something else. Then you times y. Now this y, here you have this extra y. Then after that, here you see another function of x, right? This is what we call qx. But in this part, you have an extra y to the power of something. So we write it as y to the power of n. And this is what you get. Well, for this, how you should solve it? Okay, if we remove one part, let's just say we will remove this part. That's that the rest we can solve it by using the if or the integrating factor. Then we'll need to let u be y to the power of 1 minus n. Then we just continue to solve it like this. So let's take a look at what we'll get for this case. So, well, this type 1 minus 3 over 5. That means it is 2 over 5. And that means y will be u to the power of 5 over 2. Okay, fine. You get something like this. You get something like this. But how about this y prime? Well, of course, you still have to find it. And of course, you have this u prime. Okay, let's take a look. Now the next step is to stuff all of these inside. Okay, so we get something like this. But as I've mentioned just now, we want to use the integrating factor or the IF. Then with this part, we need to change it into this form, U prime. After that, all the others will just follow. Okay. So here you get 2 over 5. Then after that, U. But be careful, this one is to the power of 5 minus 2. Therefore, you have to minus in the power 3 over 2. So that means it's just U. And then this would be equal to 2 over 5. Then here's 1 minus x. Nope, you don't have another U. Because here you times U to the power of negative 3 over 2. And here's a U to the power of 3 over 2, so that means it cancels out. Okay, so that means here you won't have anything else. Now in this form, we can use the integrating factor now, the IF. But wait, think about this. What changes have happened to let us allow to use the integrating factor? Think about it. Okay, so answer is coming up. Well, what allowed us is, at first, this is non-linear. But after we made this kind of substitution, it magically gives us a linear ordinary differential equation. So it's just from non-linear to a linear just by the method of substitution. And that allows us to solve the whole thing. If you straight away come from here and you don't use the substitution, well, I'm not sure what other methods you can use right now. Okay. But right now here we're going to use this type of method. Okay? E to the power of this thing. Okay. So just what I think can be simple integration. That's it. This is a ln. This is the e. How about putting this down? Which gives you 1 minus x, then to the power of 2 over 5. So get this. Okay. You get this thing. Now, IF, what did we use? That was times on both sides. Okay, you get this thing. But you don't simplify this out because we just times on both sides. You don't go and just simple them out. Simplify. Okay, so right now on this part, we can use a method. Now what is it? And for this method, we will be using is total differentiation. Okay, so we use the total differentiation. So that means this whole thing just goes in. Then with both sides integration, then just few more steps. we can actually get what we want. So firstly, just finding out this integration. Here, this part simple. Just writing this again. Then this part will be something else. So then with this part, you need to add 1. That means it is 12 over 5. 12 over 5. Bring it down. After that, when you times something, you still have to get 2 over 5. That means it can only be a 1 over 6. Then here will be your arbitrary constant. But wait, think again. We have done for the outside here. How about inside? Did we miss something? Of course, yes, we did. This negative x. Negative x, you need another negative. Negative here, okay? Next. Okay. So we got this right now. We'll need to put this back again as we want to find y. So then with this y to the power of 2 over 5 will be, okay, we need to divide this to the other side. Square. Now why is it square? Well, it's just 12 minus 2, then 10 over 5, then get 2. Okay. So that means it'll be like this. And in just one more step, you'll get what you want, the y. And there, you just get your answer. But now, wait. You have to be really careful here. Although you might just put it like this, but beware, here's over 2. Over 2 in this power means that there's a square root. Now, what thing do we need extra if, for example, the power of this is even? Well, we need positive negative. Because positive negative to the power of even number of times, well, it's still the same thing, pretty much the same thing. So that means we'll have to change this. So then it's positive, negative. Okay, you get this. But are we really sure that this is the right answer? I don't think we're really sure right now. So the next thing to do is to verify. Now, how do we verify this? Would you rather use this step or this step? Now, for this step, you have to consider 2 cases, positive or negative. Are they right or wrong? But this step, we just need 1 part. We don't need like this, consider 2 cases. This part, just 1 case. Okay, so let's just use this. Well, to not confuse ourselves, we'll need to write this down in case in midway we accidentally look at the next one. Okay. Now after that, check again. Okay. Next part, you start differentiating. This is what you get for the first part. Okay? Next part here, you have to be really more careful right now. Negative, beware. So negative and negative, positive. Then 2, then you only get 1 over 3 here. Then inside here, no more. Well, because it's just a 1, so we don't write it. Then here's a negative. Here's a negative, here's a positive, that means plus. Then here again, minus 1. Like this. Alright, so far? The next part. What will we have? Maybe we can try to simplify things a little bit. What shall we use? How about we change this part to something else? So that means that this part, you can try using this. Okay, so that means this one you change. So you get like this. Then after that, you can try a little bit of expansion. Wait, this part, you have another of this. Well, then that means here you get a half. Then after that, here you want y prime, so give y prime. So at this part, times, here also divide. So in front here, 5 over 4, right? Okay. Then after that, y to the power of, here is 3 over 5. Then after that, wait a second, I think we missed out one part here. There's this 2 over 5. So I think we missed out on that part. Yes, this is a 2 over 5. Okay, so sometimes you still have to check again, in case you like just accidentally missed out one part. Okay, so always remember that you need to check again. Okay, so I think this part is alright right now. So at this part, what do you have? Okay, this part is still simplified out. Then this you get y. Okay, you have this part. Then after that, it's just pretty much the same already. It's just a little bit of changing. And there, you get it. And that means what we got here is all right. Okay, so I hope that you can understand so far in this lesson. So if you like our videos, don't forget to subscribe to our channel. And thank you for your watching.